The diesel particulate filter system, DPF, appeared on the European market late in 2000. There are now two basic configurations of this system. The first requires the use of a fuel additive to periodically regenerate the particles stored in the filter, whereas the second does not need such an additive in the process. In this video, we will explain the basic operation of the DPF system with fuel additive. These kinds of systems have mainly been used in Peugeot and Citroën vehicles since 2001. The basic components of a DPF system with fuel additive are electronic control unit or electronic system calculator, diesel particulate filter with oxidation catalyst, broadband lambda sensor pressure control system comprising differential pressure sensor, pressure pipe in front of the particulate filter, pressure pipe behind the particulate filter, temperature sensor, tank, pump and fuel additive injector circuit, fuel cap opening magnetic sensor, when refueling, the fuel cap opening sensor will send a signal to the electronic control unit to record the number of litres in the tank. After refueling and refitting the fuel cap, the filling sensor will send a new impulse to the electronic control unit to make it count the number of litres of fuel that have been put into the tank. With this information, the electronic control unit will precisely calculate the amount of additive that has to be injected into the diesel tank and will send the signal to the pump of the additive circuit to put this amount into the tank. The operation of a diesel particulate filter is simple. These units filter the exhaust gases and retain the accompanying solid particles in a filter, thus preventing them from escaping into the atmosphere. The fuel additive used in these systems is a combustion catalyst, that is, a substance added to the fuel which, when burnt in the combustion chambers, adheres to the outside of the solid particles travelling with the exhaust gases and is trapped with them in the particulate filter. When regeneration occurs, this fuel catalyst, which is usually a metal oxide, adds oxygen to the oxidation reaction to accelerate burning of the solid carbon particles held in the filter. The use of these catalyzing additives allows regeneration to take place around 100 degrees centigrade below the normal temperature, making it faster and more efficient. With use, the particles accumulate on the walls of the filter, making it difficult for the gases to leave. This accumulation is monitored by the electronic control unit by the differential pressure sensor that detects the change in pressure between the pressure pipes in front of and behind the particulate filter. When the pressure difference reaches a certain level, a program is activated that raises the temperature of the exhaust gases above 550 degrees centigrade, and the particles in the filter are burnt and turned into carbon dioxide gas, which passes through the filter, leaving it clean and ready to continue filtering. This process is known as particulate filter regeneration, and under normal driving conditions takes place periodically throughout the life of the unit in intervals that range from 400 to 600 kilometers. Unfortunately, this regeneration process is not perfect, and it leaves a small solid residue from the cerium oxide, which is the catalyzing element of the additive, and other solid compounds such as phosphorus from the oil, which accumulate on the walls of the particulate filter. This gradually limits the filter's capacity to allow the gases to pass, increases the back pressure on the system, and means that this unit needs to be replaced after between 80 and 140,000 kilometers. Due to the nature of the compounds deposited in the filter during the regeneration, cerium oxide, ash, phosphorus, and the fact that it is virtually impossible to clean these units and to leave them as new, Walker, the world specialist in emissions treatment, recommends only replacing the particular filter units with new ones. The accumulation of these residues in the particulate filter considerably shortens its useful life, having a negative effect on the vehicle's power and its fuel consumption, which will increase appreciably in comparison with the use of new systems. Whenever a particulate filter is replaced due to wear, Walker also recommends changing the catalyst, giving that its useful life is similar to that of the particular filter, and if this fails, the regeneration process is not possible, so the filter cannot be emptied and its integrity and that of the engine will be compromised. As a general rule, these parts must always be changed as a set.